For today's video, we will answer a math challenge given by one of our followers. And the question goes like this. Solve for the value of n that satisfies this equation n factorial raised to the power of 2 over n minus 3 factorial multiplied by n plus 1 factorial equals 3 over 2. Now you can pause this video if you want to give this problem a try. Now suppose you pause this video. Now let's see if your answer is correct. Alright, so to answer this question, what we're going to do is to focus first on this n factorial raised to the power of 2. We can write this as n factorial multiplied by n factorial. Now, what we're going to do is to use this identity. Take note, when we have x factorial, this can be written as x multiplied by x minus 1 factorial. Because 3 factorial, we know, this is just 3 times 2 times 1. And this 2 times 1, we can write this as 2 factorial. So, 3 factorial can be written as 3 times 2 factorial. Alright. Now, let's focus on this n plus 1 factorial. Using this identity, we can say that n plus 1 factorial can be written as n plus 1 multiplied by n plus 1 minus 1 factorial. Alright. Now, n plus 1 minus 1, positive 1 and negative 1, this is just 0. So, we have n plus 1 multiplied by n factorial. And this n factorial, we can write this as n factorial like this. Now, your question is, what is the purpose of doing this? Why we rewrite n plus 1 factorial into n plus 1 multiplied by n factorial? Because notice, we have n factorial on the numerator and n factorial on the denominator. So, we can definitely cancel these two terms after we simplify some factorials. Alright, now at this point, let's focus on the remaining n factorial. So again, we can now eliminate n factorial and n factorial later on. But how about this n factorial? How can we rewrite this n factorial? So our goal is to eliminate n minus 3 factorial, of course. So using this identity, n factorial, we can write this as n multiplied by n minus 1 factorial. Now, how about this n minus 1 factorial? Again, using this identity, we can write this as n minus 1 multiplied by n minus 2 factorial. Next, let's focus on this n minus 2 factorial because we don't see any n minus 3 factorial on the numerator. So now, n minus 2 factorial, if we simplify this using this identity, we get something like n minus 2 multiplied by n minus 3 factorial. Now, we will stop at this point. Now, the reason, we have n minus 3 factorial on the numerator and n minus 3 factorial on the denominator. So, we can cancel out the factorial. And also, a while ago, we said that we can cancel this n factorial and n factorial on the denominator. So, now, we don't have any factorial in our equation. So, what we're left is n multiplied by n minus 1 multiplied by n minus 2 over n plus 1 equals 3 over 2. Next, to solve for the value of n, again, we don't have any factorial in this equation. So, what we're going to do is to cross multiply. So, these 2 multiply on the numerator and this n plus 1 multiplied by this 3. And if we do that, we get 2n multiplied by n minus 1 multiplied by n minus 2 equals 3 times n plus 1. Now, if we multiply n minus 1 multiplied by n minus 2 using some algebra, we get n squared minus 3n plus 2. So, we can replace this factor with n squared minus 3n plus 2. Next, how about if we multiply 2n to n squared, negative 3n, and positive 2. If we do that, we get 2n cubed. 2n times negative 3n is 6n squared. 2n times 2 is 4n. So we can replace this with its equivalent. And the last one, let's distribute this 3 to n and to 1. And sure enough, we get 3n plus 3. Next, let's combine like terms. Let's subtract 3n on both side. So to eliminate 3n on the right hand side, so this will give us 2n cubed minus 6n squared plus n equals 3. And then subtract 3 on both sides. And now, what we're going to do is to group these terms. Now, what is the reason? The reason is we can factor out 2n squared in these two terms. And if we do that, we get something like 2n squared multiplied by n minus 3. And take note, we have also n minus 3 right over here. So now let's have its factored form. And now we have a common factor of n minus 3. So we can factor out n minus 3 in this term. And if we do that, we get n minus 3, the common factor, multiplied by 2n squared plus an imaginary 1. So let's have plus 1 right over here. So let's have the factored form. And since it is equal to 0, so we can use the 0 property. So we can say that n minus 3 equals 0, or 2n squared plus 1 equals 0. Now, in the first case, let's solve for the value of n. So let's add 3 on both sides. And if we do that, we get n equals 3. This is a valid solution for n. Now, how about on the other case? Let's subtract 1 on both sides and let's divide by 2. So n squared equals negative 1 over 2. Now, this is not possible because if we get the square root of a negative number, we get an imaginary number, which is not possible for n. Therefore, this case is not possible, is not accepted. So the only value for n in this equation must be equal to 3. Now, let's check our answer if our answer is correct. Of course. Now, we have 3 factorial raised to the power of 2. Now, 3 factorial, we know this is 6. 6 raised to the power of 2. So the numerator is just 36. Now, how about on the denominator? If we have n minus 3, so 3 minus 3 is 0. So 0 factorial is just 1. So we can eliminate this. And this n is 3. 3 plus 1 is 4. So 4 factorial, we know this is 24. So the denominator is 24. Now 36 over 24, divide both by 12. And sure enough, we get 3 over 2. Therefore, our answer is definitely correct. And as always, we are done.